Bismillahirrahmanirrahim. Assalamu alaikum and hello to everyone. This is Maria Khan from mymathsclub.com, and as I have promised, I am here with the second part of transforming higher degree polynomials to quadratic, and we'll learn how to factorize them after transforming to quadratic equation and get the solutions. So here I have just selected a few examples here, which is going to help you with some more enrichment, and it is going to help you how to handle some typical looking higher degree polynomials, which basically looks like rational expressions or equations. So how we just turn them into polynomial, and then how we transform them into quadratic, and then how we factorize them. That's each and everything we are going to cover in these examples. So without wasting any further moments, let's get started. So let us take out the LCM and try to get a polynomial structure here. So once when we take the LCM, what we are having here? We are having 1 over here in the denominator, and here we are having x cube in the denominator. So once when we take the LCM, what we are having in the LCM? Product of common and uncommon factors. So x cube is going to be the LCM, of course. Yeah. So now, what shall I write over here and here? As I told you already in the beginning, that while writing your term at this position, there's the first position, you pick up your first term, you multiply it with your LCM, which is x cube. What you're getting x power 6. You add up the powers. Whenever the base are same and they're getting multiplied, you add up the powers. So this is x power 6. So over here you just write x power 6. I hope it's clear. So this is it. And then similarly at the second place, what you do, you pick up your second term, you multiply it with your LCM. X cube and x cube get cancelled. What is left is 2. So we just write 2 here. Clear? And now, and now you see, you just shift this x cube over here, it will get multiplied with 3. So you're having x power 6 plus 2 equals to x cube. Yeah, and then you shift this x cube at the left side. This is going to be the structure finally, and this is a polynomial of degree 6. Okay, and you can see that it is containing 3 terms. So this is a trinomial of degree 6 in such a way that the middle term that you can see is having the power which is half of the degree. So it is reducible, or it can be transformed or converted into quadratic. So how we are going to convert it? By assuming that let the midterm variable along with its power is equals to some other variable. You pick up any variable you want. I say I pick up t here this time. Okay, so let x cube equals to t this time. All right, now once when you take square, when you square both sides, you come to know that x power 6 is equals to t squared. Yeah, so at the place of your x power 6 you write t squared, the place of your x cube you write t plus 2 equals to 0. This is a nice quadratic format. Now we need to factorize this. Okay, so I copy t squared, copy this sign, I copy plus 2 with a nice gap in the mid, and now I need to find out the pair that I should adjust here at these two positions. Okay, so I'm having constant value 2. I will multiply it with the coefficient of the highest power variable, which is 1. So I'm having 2. So let us try to find out the factors of 2, which is nothing but 1 and 2. Okay, so the factors of 2 are 1 and 2, and this pair on subtraction giving you the coefficient of the middle term.
Yes.
Yeah. So now 2t plus t. There you go. And now let's get the factors. So in the first 2 terms, t is coming common, you take it out. T minus 2 is left. Plus is copied as it is. Now in the last 2 terms, nothing is coming common. It means 1 is there. Okay, there's no need to write 1, it's understood. Okay. Here there is a little mess. That's 3x cube. My bad. I'm sorry. So this is, let me just use a different color, make a rectification. You see, this is a 3x cube. I forgot to write 3 here. So this is 3. Okay, everywhere I'm having 3. Okay, sorry for that. So wherever you're having your 3, so this pair on addition is giving you the middle term coefficient. Okay, so let me just adjust everything here. Yeah, so this is 3t. Okay, so 2 and 1 on addition giving you the middle term coefficient. So I'm having minus 2t minus t. This is it. Okay, now minus and 1 is common. So inside the bracket, t minus 2 is left. There you go. Equals to 0. Okay, now minus 2 and minus 2 is going to be considered your first factor. That's minus. And this is going to be your second factor, t minus 1 equals to 0. There you go. And now what to do next? The next thing that we need to do is to restore. What was our t here? T was equals to x cubed. Yeah. So we just write x cubed minus 2, and this is x cubed minus 1 equals to 0. Okay. Now you can notice that 2 is not cannot be expressed as a perfect in a perfect cube order. Okay, so you just leave this factor as it is. This is a cubic factor, and over here we can make an adjustment. Okay, in the second, so you can see that 1 can be written as 1 cube. Okay, so x cubed minus 1 cubed. Now over here in the second factor, you can further factorize it with the help of this formula, a cubed minus b cubed, which is equals to your a minus b times a square plus ab plus b square. Okay, that's it. So finally, x cubed minus 2, and over here this is my a, x is my a, and 1 is my b. Okay, just for understanding. So this is x minus 1, x is square plus x plus 1 is square, which is 1. So you can notice that you are having, though you're having it looks like you're having just 3 factors. So basically the ones when you try to add up the degree of all these factors, you're having the degree of the basic equation that was given, that was 6. You see over here, this factor is having degree 3, this factor is linear, is having degree 1, this factor is quadratic, which is degree 2. You sum up all these degrees, it is giving you 6, which is the degree of the basic equation, which was this. Okay, so our factors are just fine. What we need to do next is to find out the values of x. Okay, so you are going to do what? Equate all these factors one by one to 0, and that's how you're going to sort out. So let's try to get the values of x one by one. By equating all these factors to 0, x cubed minus 2 equals to 0. Okay, so here I come to know that x is 1, this is 1 root, and as far as this quadratic equation is concerned, you see you cannot use midterm breaking here. Okay, because this is going to give you irrational answers, so you better use quadratic formula to get the 2 answers of your x. Okay, over here. So what to do? Let us use the formula. You can see that over here, if I compare this equation with the general quadratic form, I can get my ABC values. Where a is 1, b is also 1, and c is also 1. Yeah, so I can use now these values in my quadratic formula to get the 2 answers of my x. Okay, so x is equals to minus b plus minus under root b square minus 4ac upon 2a. Yeah, so now what I'm going to have, I'm having minus 1 plus minus under root 1 minus 4 upon 2. You can notice you are going to have complex answers. 1 plus minus under root minus 3 upon 2. Are you getting me? So x is equals to minus 1
Yes.
plus minus iota under root 3 upon 2. So you're having two answers over here, and both of them are complex. Okay, now we are going to sort out this last cubic factor. So let me close this thing in a box. Okay, and now x cubed minus 2 equals to 0. Let's come a little up. Okay, finally x cubed minus 2 equals to 0. So you shift this 2 on the other side, becomes x cubed equals to 2. Now I need to find out what? I need to remove this cubic power from the x. So how I'm going to remove it? I can remove it by applying my cube root at both sides. Are you getting me? So how? Cube root is actually this, and you know the power of cube root is 1 upon 3. Yeah, so you apply cube root at both sides. Okay, so cube root is going to cancel your cubic power, so x is left, and x is equals to cube root of 2. So you're having 3 repeated real answers, which is this cube root of under root 2. These are the 3 points which are overlapped on one another, and one answer is 1 and 2 are the complex answers. So once when we try to plot the graph of this degree 6 polynomial, you will see that you are going, that curve is going to intersect your x-axis at 2 points. This is your 1, and this is going to be your cube root of 3. I don't remember what is going to be the value of cube root of 3 in decimals. I must check. It probably, maybe it is going to be less than 1. Let me just check it out. So in that way I would be able to draw it well. Or else I can also use my decimals calculator to give a good picture. I think I must use that instead of drawing it roughly. So let us just check it out. Cube root of 2 is 1.25. Okay, the cube root of 2 is 1.256. Okay, so it is greater than, so I'm fine. So that's how you see 3 points are overlapped on each other. That's why it looks 1, just 1 point, and the other one is 1, and the remaining 2 points are actually complex, so they're not going to be visible on your real graph system. So you're having 6 answers, out of which 4 are real, okay, and 2 are complex, and out of those 4, 3 are real and repeated, which is cube root of 2. So this is it. That's how we do. Okay, so I must say that this is a degree 6 polynomial questions. Basically they don't come in the exam, but just for saturation I explained you that what exactly happens if you handle higher degree polynomials, higher than 4. Okay, now I'm going to pick up square root type questions. Okay, so okay, this is it. Now let's try to sort out this thing. What we need to do, let's take the LCM first of all at the left side nicely. So you see LCM over here is simply x. Now I'm going to do it a little direct because I've explained you how these values are going to come, which I'm writing on the numerator. So 7 upon under root x, that's what I'm having. Now you can notice that x can be written as product of under root x 2 times. Okay, so how? You see x is equal to, if I multiply my x power half with another x power half, you see you add up the powers like this. Half plus half is 1, so you're having x power 1. So x can be written as under root x multiplied by under root x. Yeah, so 2x plus 3 upon, I can write my x as under root x multiplied by under root x equals to 7 upon under root x. Clear? Now 1 under root x is going to cancel with this under root x, because if you're having common multiples on both sides of the equality, you can do horizontal cancellation. I hope you know this. So we did a horizontal cancellation, and now we are having this thing so left. Now shift this under root x on the other side, it will get multiplied with 7. So 2x plus 3 is equals to 7 under root x. Now shift this right hand side term on the left side. Let me just do it here. So it is x minus 7 under root x plus 3 equals to 0. Now you can see that it is also higher degree is 1. It looks like it is containing 3 terms. Okay,
Yes.
so it looks like linear, but as you can see that the middle term power is half of the highest power variable, half of the power of half of the degree. Yeah, so half, as it is satisfying the situation of transformation into quadratic form. So you can transform this type of equation into quadratic. Yeah, so by letting your middle term variable along with its power equals to some other variable, I call it y. Okay, and now once when I square both sides, I'm going to get x equals to y square. That's what I'm going to replace. Okay, so this thing tells me that this equation can be transformed into quadratic. This equation, which seems to be linear, it is linear indeed, so it can be transformed into quadratic. So we just did that. There you go. Now factorization we are going to perform. 3 into 2 give me 6. What are the factors of 6? 1 6, 2 3, and first pair on addition giving you 7. So 2y square minus 6y minus y plus 3 equals to 0. So 2y is common, y plus y minus 3 is left, and over here minus 1 is going to be taken out common. Y minus 3 is left again. So now y minus 3 is my one factor, another factor is 2y minus 1 equals to 0. Okay, and now restore the original form. Y was equals to what? Y was equals to under root x. Yeah, so replace your y, get the original factor, and now we are going to equate these two factors to 0 to get the values of our x. Okay, so let's do it one by one. So under root x minus 3 equals to 0, and 2 under root x minus 1 equals to 0. So now under root x equals to 3, you square both sides to get rid of this radical, because it is square root, so it is gonna be cancelled by taking square at both sides. So while squaring, it's giving you 9. Okay, one answer is this. And now similarly, same thing you're going to perform here. 2 under root x equals to 1. So under root x equals to half. You square both sides, so x equals to 1 upon 4. This is another answer. Okay, so once when you plot this equation and you get the graph of this equation, this box equation, it is going to intersect your x-axis at these 2 points. How about if we just check this time using Desmos graphing calculator? Just hang on for a second. Okay, so once when we try to plot this equation, where it is, it's roots. Y equals to 2x minus 7 under root x plus 3. Okay, so it is y equals to 2x minus 7 squared, yeah, under root x, and then plus 3. So you can notice here, this is it. This is 1 point, which is 0.15, which is 1 upon 4, and this is your 9. That's what we were having here. Okay, so whenever you have a linear equation that contain one of the term that is one of the variable that is radical, I mean if it is square root or cube root, something like that, so always you're going to have answer which is equals to the index of that radical. You see, you are having this under root x involvement in that equation, so there's a square root, so you see index of square root is 2. Okay, so that's why you're going to have 2 answers, 2 roots. If you're having a simple linear equation of this format, you're always going to have, of course, 1 answer. But whenever you have a linear equation involving radical there, then the solution will be equal to the index of that radical. Okay, I hope it's clear. So guys, if you find this video helpful, I request you to subscribe my channel and hit on the like, and share this video as much as you can with your friends and other learners, so they will also get help. And I'll see you then with some other beneficial and helpful video in future. Till then, just take good care of yourself, practice well, score good. Allah Hafiz.